Hi, I'm Kevin, and I'm here to talk to you about troubleshooting the thrust reverser fault system on the Boeing Model 737NG airplane. In this presentation, we'll cover proper troubleshooting methods and best practices for getting your 737 Next Generation airplane back into service after a thrust reverser or TR system fault. We'll discuss the initial steps to take, common troubleshooting examples, and best maintenance practices. If a fault occurs within the TR system during any phase of the flight cycle, the reverser light will illuminate. In other occasions, the engine control light will illuminate. For this training, we'll focus on faults that result in reverser light illumination. In any of these cases, before any troubleshooting is performed, it's important that the maintenance personnel observe what is physically happening with the reverser, review the pilot report, and most importantly, record which faults are observed at the engine accessory unit, also known as the EAU. First, document whether the TR failed to deploy or stow during operation. Did you hear any unusual noises coming from the sleeve during operation, such as chattering or squealing? Note which sleeve this occurred on and whether you noticed any leaking hydraulic fluid in the vicinity. If there's a noticeable lag between the two sleeves, take note of the amount of time that the delay is taking. Next, review any pilot reports of whether the rev light changes colors appropriate to what is being observed during actuation of the reverse thrust lever. At times, the flight crew may note odd behavior with the reverser or with the rev light. You may also confirm this while following the steps in the AMM task under Thrust Reverser Normal Operation Test. Noting these details will be helpful and provide significant clues for determining the root cause of the TR fault. When there is a fault with the 737NG TR system, you or the flight crew may experience difficulty with physically operating the reverse thrust lever. It's important to note whether the lever is able to move past the interlock. Noting where and when issues arise while moving the reverse thrust lever can help in diagnosing the TR system fault while you are using the fault isolation manual later on. Also, take note of when the reverser indication light was reported: post or pre-flight, during takeoff, in-flight, landing, or taxiing. Afterwards, performing the EAU built-in test evaluation or bite check is absolutely necessary. The EAU is located in the electronic equipment or EE bay on the E32 shelf. The EAU is a simple fault box that does not retain memory of the prior faults after the reset button has been pressed, or after the reverser has been cycled 5 times. Resetting the faults without recording them first will make the problem much more difficult to isolate further down the line. From 2012 to 2014, over 50% of service interruptions due to reverser indications could have been avoided if EAU faults were written up as they were observed. A faulty thrust reverser system can, at times, be intimidating to isolate without any clues. Along with your initial observations, the EAU fault codes will provide nearly all the information you'll need to get the airplane back into service. Remember, never reset the EAU before recording all active EAU fault lights. Never cycle the reverser 5 or more times before recording all active EAU fault lights. And never cycle the reverser quickly to confirm if the fault is still active. Now let's take a closer look at the EAU and the fault isolation process. The Fault Isolation Manual, Chapter 7831, Task 801, may be followed along with for this process. The EAU monitors the sleeve stow and lock proximity sensors, the hydraulic isolation valve, or HIV, and the directional control valve, or DCV proximity sensors, and the voltage input to each sync lock. The EAU byte procedure will show if one or more of these inputs are not in their commanded state by the illumination of the fault lights. Perform the EAU or M528 byte test at the front panel of the EAU. The front face of the EAU contains separate fault lights for engine 1 and engine 2, and maintenance messages for each light. Also, on the front face of the EAU for each engine are these items: TR Stow faults, light and switch, TR deploy faults, light and switch, and fault reset switch. Faults that occur when the thrust reverser is commanded to stow are stow faults and will cause the TR stow faults light to come on. Faults that occur when the thrust reverser is commanded to deploy are deploy faults and will cause the TR deploy faults light to come on. The EAU fault light will come on if there is an internal fault in the EAU. This will generally be the only fault light that would require replacement of the EAU box. The EAU keeps faults in memory for only the last 5 stow and deploy cycles. All of the data is shown together, and all of the data is cleared when the EAU is reset. This is why it is so important that the EAU must not be reset or cycled 5 times before recording the faults. Once the data is cleared, you won't know what was wrong with the TR system until the TR experiences a fault again in the next cycle, which may result in another service interruption. Now, let's go through the byte check procedure. If the TR stow faults light is on, first push and hold the TR stow fault switch on the EAU for the applicable engine. Note, all the fault lights will come on for 1 second. After 1 second, all the lights will go out except for a light or a combination of lights that indicate a fault. Next, release the TR stow fault switch. Record the maintenance messages that are related to the lights. Note that they were stow faults and which engine they occur on. Now, to show the maintenance messages related to the most recent cycle, first, push and hold the fault reset button for a minimum of 2 seconds. Wait for at least 30 seconds. Now, push and hold the TR stow fault switch and then record the current maintenance messages that appear. Note that they were stow faults and which engine they occur on. Now, if the TR deploy faults light is on, push and hold the TR deploy fault switch on the EAU for the applicable engine. Note, all the fault lights will come on for 1 second. After 1 second, all the lights will go out except for a light or a combination of lights that indicate a fault. Because the EAU stores faults from the last 5 deploy and stow cycles, there can also be maintenance messages for intermittent faults that will show. Now, release the TR deploy fault switch. Record the maintenance messages that are related to the lights. Note that they were deploy faults and which engine they occur on. Now, to show the maintenance messages related to the most recent cycle, first, move the reverse thrust lever aft to try to extend or deploy the thrust reverser. This procedure is found in the AMM task for deploying the thrust reverser. Note, some faults in the thrust reverser system will not let the thrust reverser extend or deploy. If the thrust reverser does not extend, make sure that the reverse thrust lever remains in the extend or deploy position to reset the EAU. Back in the EE bay, push and hold the fault reset button for a minimum of 2 seconds. Then, wait for at least 30 seconds. Now, push and hold the TR deploy fault switch and then record the current maintenance messages that appear on the EAU. Now, with the fault codes that you have recorded on hand, refer to the table at the end of FIM 7831, Task 801, to find the applicable fault isolation task for the maintenance message or messages you recorded. If a single maintenance message shows, then do the applicable fault isolation task. If there is more than one maintenance message that shows, then do the fault isolation task for that combination of maintenance messages. For example, if you see the following messages, you'll perform FIM 7832, Task 812, which will address this combination of messages. Once you've identified the right task to perform, refer back to your recorded observations and pilot reports. After you compare your notes with the FIM task, you should be able to more quickly identify the root cause of the TR fault. Remember, the 737NG thrust reverser system is not as difficult to troubleshoot as it seems. The very first steps to identify and record the issues and fault codes, however mundane, will make solving the problem much easier. So again, follow the steps, and before you know it, you'll have your airplane back in business. Thanks.